Good day, learners! Welcome to Math is Fun with Sir O. Today, we're going to review some of math lessons of grade 9. We're going to solve some problems under equations with radicals, introduction to radical functions, and introduction to complex numbers. Are you ready? Come and join me. Let's start. Okay, so welcome back, children. So I'm going to share a screen here so that we can start now with our review in mathematics. So today we're going to recall what are the things that we have done from the past, and let's start reviewing with equations with radicals. So before we do that, children, let's know first the power rule. So for example, if we are given like the square root of 3x plus 4. So our goal here is that we're going to get the value of your x. Okay, so the square root of 3x plus 4 is equal to 8. Okay, so again, we're using the power formula. So we're going to express this into its power form. So how are we going to do that? How are we going to do that, children? Yes, AJ. All right. Children, please react. How are we going to do this? All right. So we're going to get the value.
Multiply sa exponent of 2, sir.
Yes, correct. So we're going to express this into exponential form. Very good, French. So the square root of 3x plus 4 is actually equal to the... Okay, so this is 3x plus 4. Quantity, this is 4 quantity, and then we're going to raise it to 1/2 because square root means in exponential form that is equal to the power, or that is equal to the 1/2 power. Okay, then equals to 8, right? So to eradicate our 1/2 as our square root or as our power here, we're going to express, or we're going to raise the whole equation with 2. Okay, we're going to raise it to 2, right? So using your power formula, so of course if you are raising this to 2, we're going to distribute this 2 here to the left side, so that is 1/2. Okay, raised to 2, and then this is also 8. Then we're going to distribute it here, right? So that's gonna be 8 squared. Of course, we know that 1/2, okay, 1/2 times 2. So we're going to multiply 1/2 and the power outside, right? So we're going to get 3x plus 4, that is equal to 1 times 2 is equal to 2. Then here we have, as we know that the denominator of our whole number is always equal to 1, so that is 2 times 1 will give us 2. Now let's express 8 squared. So 8 squared is equal to 8 times 8. 8 times 8 or equal to 64. Okay, so again, 2 over 2 or 2 divided by 2, that is equal to 1. So meaning, children, this is actually equal to 1. So we can express this as 3x plus 4 equals 64. Now we have here our new equation. So our goal again is we're going to get the value of our x. Okay, so the next thing is we are going to, yes, we're going to transpose all of our, what do you call this one, children? It has no variable. It starts with letter C. Constant. Okay, so we're going,
Constant.
yes, so we're going to transpose our positive 4 or our constant to the right side of our equation. So that is 3x. So what will left here is 3x equals 64. Then if you're going to transpose positive 4 to the right side, it will become negative
Negative 4.
Okay, so let's simplify this. So copy 3x equals 64 minus 4 will give us 60. Okay, then we're going to divide both sides with whatever is your coefficient of x. So we're going to divide it by 3. And then if you divide by 3 here on the left side, that is the same thing that you're going to do here on the right side. So we're going to divide your right side with 3. Okay, right, so let's divide. So 3 divided by 3 will give us 1, or that will be cancelled out. So what will left there is your x equals, then 60 divided by 3. So 6 divided by 3 is equal to 2. And then 0 divided by 3 is equals to 0. And our final answer is x is equal to 20. Alright, did you have the same answer, children? Yes, that is our answer. Alright, so now I want you to get your notebook. Okay, so we're going to check if our answer x is equal to 20 is correct. So how are we going to check our answer? So we're going to go back to our original equation. Okay, so I'm going to erase this. Okay, then we're going to substitute the value of our x, which is equal to 20. Right? Alright. Okay, so let's copy. Oh, wait. Alright, so that's gonna be square root of 3. We're going to replace your x there with 20. So that's 20 plus 4. Children, don't forget to make your radical sign longer because 4 there still included in our square root, then is equal to 8. Then we're going to multiply your 3 and 20. That will give us 60 plus 4. Don't forget your radical sign. Square root equals 8. And then let's simplify the numbers inside, which is 60 plus 4. That will give us 64. Don't forget your radical sign. Okay, don't forget your radical sign. This is going to be 64 equals 8. Then the square root of 64 is equal to 8, which is actually equal to our answer. So if you have the same answer, the left and the right, that means the value of x that we have obtained earlier is correct. Any question for power? Any question? Alright, so now children, I'm going to give you like 2 minutes to solve this. Okay? Right, I'll give you 2 minutes to solve this. Okay, let's admit Rovi Ellyza. Alright, so this time children, I want you to practice solving this one because maybe I could include this in your exam on Thursday. So this is 2x, the square root of 2x minus 3 equal to 1. Alright, so I want you to get the value of your x. Okay, solve on your seats right now. Then after 2 minutes, I'm going to get back to you. Okay, see you children after 2 minutes. Right, so you're done already children. Our 2 minutes is already over. Alright, so what is your final answer? What is your final answer? Chauncy. Chauncy, what is the value of your x there? 2. Okay, we're going to find out if your answer is correct. So now let's proceed with the solution. Okay, so the first thing is that we're going to express this term, the square root of 2x minus 3, to its exponential form. So that will become the quantity of 2x minus 3 raised to 1/2 equals 1, right? And the next thing that we're going to do, since our power is 1/2, the denominator is 2, then we're going to raise the whole equation with 2. Okay, so we're going to distribute this to the left and to the right. Okay, so on the left we have 2x minus 3, or I mean the quantity of 2x minus 3 raised to 1/2 multiplied by 2. Okay, here on the right side of our equal sign, that's going to be 1 raised to 2. Do you follow, children? Alright.
Yes.
My voice is not clear. Alright, so it might be with your signal as well. Okay. Alright, so let's continue now solving this. So that's going to be 2, or the quantity of 2x minus 3. We're going to multiply 1/2 and 2. That's going to be 1 times 2 will give us 2. And then 2 times, of course, we have the denominator of your whole number, which is equal to 1. That will give us also 2. So 2 over 2 here is actually equal to 1. And equal to, what is 1 squared, children? What is 1 squared?
1.
Yes, correct. Because we're going to multiply 1 twice. So that's going to be 1 times 1, which is equal to 1. So now we have this 2x minus 3. So if we're going to simplify this, because we have only 1 as our power there, so no need to solve, no? Because we know for a fact that any number or variable raised to 1, the answer is the same. Okay, so equate it with 1. So the next thing that we're going to do is we're going to transpose your constant, which is negative 3, okay, to the right side of your equal sign. So that's going to be 2x. So transpose your negative 3 to the right side. So that is equal to 1. Your negative will become positive. Okay. Negative 3 will become positive 3. So now we have your 2x equals 4. Okay. So let's continue here. So 2x equals 4. Right? So next thing is that we're going to get rid of the coefficient of your x. So we're going to divide both sides by 2. Okay? So divide your 2x by 2, and we're going to divide 4 by 2. By the way, children, if you are showing your solution, make sure that if you have a fraction, always put the equal sign in between. Okay, hindi pwede dito sa babaw. Okay, in between ka dapat, right? So your 2 and 2 will cancel out because 2 divided by 2 is 1. So what will remain there is your x equals, then you divide your 4 by 2, that's 4 divided by 2 is equal to 2. Alright, very good, Chauncy. So Chauncy's answer earlier is equal to 2, which means his answer is the same with our answer. Now we're going to check our answer if that is correct. Okay, to make sure that everything is correct. So we're going to substitute your 2 inside our original equation. So that's gonna be the square root of 2x minus 3 equals 1. Right, so you replace the value of your x, so that is equal to 2 times 2 minus 3, but don't forget your square root there, that is equal to 1. So 2 times 2 will give you 4 minus 3 square root, okay, equals 1. Children, what is 4 minus 3? What is 4 minus 3?
12.
1. So the square root of 1 is equal to 1. And if you're going to get the square root of 1, children, of course, our answer is 1. So equal to 1. So our answer here is correct since we have verified it using our the value of x, and it is actually substituted to our original equation. Alright, very good, Chauncy. Chauncy will get 10 points. Right? So any question, children, how to get your x using your power formula? Any question about that? Any question? None? I hope none, huh? Alright, so this is only a sort of review, children, because I think that everything was done from the past. Okay? Now let's proceed with the next lesson, which is radical functions. Okay, so now, children, we have here example problem on the book on page 34. If you have your books with you, you can get your books on page and open them on page 34. So we're going to find the indicated function values of the function, which is f of x is equal to 4x minus 3, or the square root of 4x minus 3. And if we have values of f of 3, f of 4, and f of 7. So we're going to continue now with our lesson on introduction to radical functions. Okay, so by the way, children, before we go to the solution of our first example, so I'm going to read here on page 34 inside your math box there, the radical expression, the square root of, or the nth root of a represents the nth root of a. So the number n is called your index. An index of 2 represents a square root and is not written. So usually, children, if you have your square root, okay, you don't necessarily put 2 here, because we understood that this example is actually expressed in square root. No need to write your index 2. But if you have your cube root, okay, so if you're going to write your cube root, don't forget always to put your 3 as your index. Do you follow, children? So same through with your fourth root. Okay, so don't forget to write your index. So by the way, children, only square root, we don't put any number as our index. Only for your cube root, for your fourth root, fifth root, sixth root, etc., etc. Okay, so again, the number that we are writing here on the radical sign is your index. Okay, that is the index of your radical sign, and it represents actually, right, it represents the root that you're going to get. Okay, so here we're going to get the root of 2, here we're going to get the root of 3, and here we're going to get the root of 4. Okay, so if the index n in the nth root of a is an odd number, okay, when we say odd number, children, so those numbers starts with 3, it's going to be 3, 3, 5, 7, 9, 11, right? So odd numbers. So according to our definition on the book, so if the index is an odd number, a root is said to be an odd root. A cube root is an odd root. Okay, so again, children, if it's an odd number like your cube root, so we call it odd root. Okay, so other odd roots have the same characteristics as your cube root. So example, you have your fifth root, you have your seventh root, you have your ninth root, etc., etc. Okay, so now let's proceed with our example number 1 on page 34 of your book. Okay, so find the indicated function values of the function. So our function there is f of x is equal to the square root of 4x minus 3. Okay, so we're going to find out, children, what is the value of your function if we're going to input f of 3? That's for letter A. And then for letter B, we're going to input your f of 4. And for your letter C, we're going to input your f of 7. Okay? Now let's have our solution. So children, let's copy our original function here. So that's going to be f of x is equal to the square root of 4x minus 3. Now we're going to replace your f of x with f of 3. So instead of writing f of x, you write f of 3 equals the square root of 4. Children, look at this one. Since the value of your x here is equal to 3, so it means that all your x's here in our original equation will be changed to 3 as well. Okay? So if your function there is 3, then we're going to multiply 4 by 3, then minus 3. Now we're going to simplify our function. So what is 4 times 3, children? What is 4 times 3? Huh? 12. Very good. Minus 3. But don't forget to write your square root. Okay? So let's simplify it further. So what is 12 minus 3? What is 12 minus 3?
9.
Yes, 9. Right? And exactly we could get the square root of 9, which is equal to what? What is the square root of 9?
3.
3. Very good. So our answer, if our function is f of 3, then our answer for the square root of 4x minus 3 is equal to 3. Now let's have your letter B solution. So this time we're going to substitute your f of 4 to our function. Okay? So f of 4. So it means that all your x's here will be changed to 4. So that's the square root of 4 times your x will be equal to 4 this time minus 3. Okay? So f of 4. Now we're going to simplify our equation. So 4 times 4 will give us 16. Okay? Minus 3. Then what is 16 minus 3, children? What is 16 minus 3? Hello? I don't have any students. Only Chauncy is answering me. How about the others? Okay, you cannot hear me. Children, please unmute your microphone. Everybody, unmute your microphone. Okay,
Yes, sir.
I want to hear your voices. Please participate in our discussion. Alright? So now, what is 16 minus 3? Hello, 16 minus 3. Okay? It's 13. So that means that is the square root of 13. So children, see, 13 is not a perfect square. So we cannot get the square root of 13. Otherwise, if we're going to do it, then we're going to think of the possible factors of 13 that we could get the value of your square root. But then again, there's no factor that is a complete exactly, there's no factors of 13 that is not actually a perfect square. So anyway, we'll just leave it like square root of 13. But if we're going to input this in your calculator, you will get an answer which is actually equal to 3.6. Okay? This is actually equal to 3.6. Right? But if your answer is expressed in radical like square root of 13, that is already considered and it's already correct. Okay? Now let's proceed with letter C solution. So this time, we're going to get the value of the square root of 4x minus 3 if we're going to input 7 as our function. Okay, what is the function of 7 there? Okay, to our equation, the square root of 4x minus 3. Alright. So this time, all your x's will be changed to 7. So 4 times 7 minus 3. So we're going to simplify our solution. So 4 times 7 will give us 28. Okay, minus 3. So don't forget your radical sign. Then what is 28 minus 3, children? What is 28 minus 3? Okay, so that is 25. And actually, if we're going to get the square root of 25, it is equal to 5. Alright? Okay, so any question about this solution? Any question? None so far? Okay. Okay, how about, children, if we're going to add, subtract, multiply, and divide your functions? How are we going to do that? Okay, so now let's proceed with some of the exercises that can be found on page 44. Power plus. Okay, so this time we're just going to add or subtract or multiply and divide our functions. Okay, I'm going to erase this right now. Alright, so page 44 of your book, children. So let's answer letter A. Okay, so if your f of x, look at this one, children. If your f of x is equal to 2 raised to 2/3, okay. By the way, your power there is actually a fraction, and your g of x is equal to 7. It should have been 2x raised to 2/3. Okay, 2x raised to 2/3 for our f of x, and for our g of x, we have your 7x raised to 2/3. Now for number 1, so we're going to get the sum. Okay, number 1. So we're going to get the sum of your f of x and your g of x. Right. So look at this one, children. So the first thing that we're going to do is you're going to add the values of your f of x and your g of x. So that is equal to, right? So replace the value of f of x with 2x raised to 2/3. Okay, copy the plus. Then replace your g of x with the value of 7x raised to 2/3. Okay, so if your variables are the same, so they have the same x's, and the powers of their variables are also the same, children, so it means that we're going to add it directly. Okay, so we're going to get the sum of 2 and 7. So 2 plus 7 will give us 9, and then copy the variable and its power. Any question for addition? Any question? None. Now let's have your number 2 on page 44 still. So that is f of x minus g of x. So this time, children, we're going to subtract the values of your f of x and your g of x. So we're going to replace your f of x here with the value of 2x raised to 2/3 minus, okay, this time replace the value of g of x with 7x raised to 2/3. Okay, right? Then examine your variables. Are they the same x's? Yes, they are the same, right? Do they have the same exponents? Yes. So which means that we're going to subtract algebraically our expression. So we have 2 minus 7. So if we're going to subtract, children, we're going to subtract the smaller number from the bigger number. Okay, so 7 minus 2 will give us 5. And the next thing is you're going to copy the sign of the bigger value. Okay, what is bigger, 2 or 7? Children, 7. What is the sign of your 7? It's negative, right? Then don't forget to copy your x raised to 2/3. Okay, children, the rule in addition of your function is that you have to look at their variables. If their variables are the same, then proceed with adding or subtracting them algebraically. Any question? Any question?
No.
None. Alright, I hope, children, you are going to do that. But I have here a question instead. What if my f of x is equal to, for example, my f of x is equal to 2x squared, but my g of x is equal to 7x. Alright, so if I'm going to add, okay, so number one, for example, we're going to add f of x and your g of x. Okay, so look at this time, children. So if we're going to do this, so we're going to replace the values of your f of x and g of x there. So f of x is equal to 2x squared plus your g of x is equal to 7x. If you're going to examine your variables, the first variable is expressed in squared, or it's in the second power. The second variable there is expressed in the first power. Question: Can we combine the numbers or not? Children,
No.
can we combine? No, exactly, French Diane. We cannot combine. So which means that this will be our final answer because we cannot combine them. It is simply because their exponents of their x's are different. We're only combining our coefficients if their exponents are the same. Same with your examples in number 1 and number 2 here in letter A. Alright? Any question? None. Okay, I hope so. Okay, so this time, children, let's proceed with your letter B. Okay, letter B. So we're going to get the product and we're going to divide your f of x and your g of x. So say for example here on page 44, our f of x there is equal to 8x and your g of x is equal to 2x raised to, sorry, it's gonna be 2, sorry, this should have been g of x, not g only, it's gonna be g of x. So it is equal to 2x raised to 2/3. Okay, x raised to 2/3. So number 1, we're going to multiply your f of x and your g of x. Children, the dot here represents that you're going to multiply your two functions. Okay, that means you're going to multiply your two functions, right? So we're going to perform our product. Hello? Can you hear me? Can you hear me, children? Okay. Alright, so this time, children, look at this. So we're going to replace the value of your f of x, which is actually equal to 8x. Hi, good afternoon, Dean Rosel. Please open your video. Then your dot there. Yes, good afternoon. Your dot there. It represents that we're going to multiply, okay? 8x Then replace the value of your g of x, which is actually 2x raised to 2/3. Okay? So this time, children, it is unique with multiplication and your division simply because they can be multiplied, our variables can be multiplied and divided independently. When I say that, children, regardless of the difference, no, if they are different, like for example, your first variable is actually expressed to the first power, and your second variable is expressed in fraction, like your 2/3, then we can actually go ahead and multiply or add the two variables. Okay, now we have your 8x times 2x raised to the third. So how are we going to multiply this? So you're going to multiply first the coefficients. So we're going to multiply 8 and 2. That will give you 16. Then whatever the value, whatever your variable is here, so just copy it. Okay, then on the power, we're going to add their powers. Okay, again, children, we're going to add their powers. In multiplication, if you're multiplying terms in our equation, then we're going to add their powers. So of course here in 8x, we know that the power is always equal to 1. So that's going to be 1 there plus your 2/3. Okay. Now let's simplify our fraction, our powers, which actually a whole number and a fraction. Okay. So copy your 16, which is your coefficient, and copy your variable. But we're going to get the value of 1 plus 2/3. Now, let's recall our fraction during our elementary days. Okay. We're going to add a whole number and your, what is this? Your fraction. So of course, children, remember that if you are adding your whole number to the fraction, so always remember that the whole number is also a fraction, only that the denominator is always equal to 1. Now, the next thing that we're going to do is let's examine the two fractions. So we have different denominator, which means that the two fractions are actually dissimilar fractions. For dissimilar fractions, we're going to get the LCD, or the least common denominator. So what is the least common denominator? So it's just simply multiply your two denominators. So 1 times 3 will give us 3. So that will be your LCD. Okay. Right? So now we are going to get our numerators. So the first thing is you're going to cover this one. Okay. Do not include this. Let's concentrate or focus in our first fraction. So we're going to first divide. So 3 divided by 1. What is 3 divided by 1? The answer is 3. Then copy here your 1. So actually we're going to multiply that to our answer, which is the quotient of your 3 and 1. Then copy your plus sign. So this time, children, you're going to cover this. Let's focus here on the second fraction. So let's divide 3 and 3. So 3 divided by 3 will give us 1. And then copy your 2. So we're going to multiply our quotient 1 with 2. Okay. So let's simplify that further. So 3 times 1 will give us 3. Copy your plus. Then 1 times 2 will give us 2. And then don't forget to, right? Don't forget your denominator 3. To copy your denominator 3. And the next thing, we're going to add our numerator. So 3 plus 2 will give us 5. Then copy your denominator 3. Which means that our power here is actually equal to 5/3. So our answer here is 16x raised to 5/3. So that's how you're going to multiply your two terms of your
Ang 1 to ya, sir. Ang duha naka 1, sir, na gano'n, sir. Ganito.
Which one? Which do you think?
Ang sa dribble, sir.
This one?
Ang sa 3, 3, may... Yung sa piyak nila, sir. Ang bago mo lang ginsolve. Ang 1, no? Ang duha ka 1.
This one?
Wait lang. Ario.
This one and this one?
Oo.
This one, no?
Okay, sir. Okay.
Okay. So 3 divided by 1, that is your quotient. 3 there. Then multiply the original numerator of your first fraction. Copy your plus. Then 3 divided by 3, that is 1 for your quotient. Then multiply that with the 2, the numerator of your second fraction. Then you're going to multiply 3 times 1 will give you 3. Copy your plus. Then 1 times 2 will give you 2. Then add the 2 numerators. Always copy your denominator, which is 3. Okay? So that would be your power for your final answer here for f of x times your g of x. Alright? Any question about multiplication? Again, children, if you're multiplying your two terms of your function, always remember that you are only multiplying your coefficients. So your 8 and 2. But your variables, you're going to add their exponents. So of course, children, if you can encounter fraction, so don't worry, children. Just recall your learnings when you are in elementary days. Okay, addition and subtraction of your fraction and whole number or dissimilar fractions. All right, so for multiplication, again, children, for multiplication we are adding the exponent of your, again, we are adding the exponents of your variables. Now let's proceed with division. Okay, I'm going to erase this. Alright, so for division, children, that is actually equal to f of x over g of x. Okay, f of x over g of x, or f of x divided by g of x. Right. So we're going to substitute the value of your f of x, which is 8x, okay, divided by the value of g of x, which is 2x, raised to 2/3. Okay, so same through with your multiplication. If you're multiplying your two terms there, you're just multiplying your coefficients. Here in division, you're also to perform division, but only divide your coefficients. So 8 divided by 2 will give you what? 4, correct. And then copy your variable. And this time, children, since we are dividing, we are going to subtract. Again, in addition, in multiplication of terms, we are going to add. But in division of terms, we're going to subtract. So which means that, okay, the numerator here, 8x, the power that you have there for your x is 1, minus the power of your denominator, which is your 2/3. Do you understand? So you're going to simplify this further. Now we have your 1 minus 2/3. So same process, children. We're going to express your 1 whole as a fraction. Of course, if you have a fraction, always remember that the denominator is always equal to 1. Okay? And then we have two different denominators that makes it two dissimilar fractions. And we're going to get their LCD. So the LCD of 1 and 3 is, or of 1 and 2/3 is 3. So just we're going to multiply 1 and 3. So 3 divided by 1 will give us 3 multiplied by the original numerator of your first fraction. Then copy your minus sign there. Then next is we're going to divide 3 by 3. So 3 divided by 3 will give us 1. And then copy the original numerator of your second fraction, which is 2. Now, let's simplify this. 3 times 1 will give us 3. 1 minus 2 will give us 2. Oh, don't forget to copy your minus sign, and of course, your denominator is equal to 3. Now we have here 3 minus 2 is equal to 1, and copy your denominator. So the answer is
1/3.
so which means our final answer would be 4x
4x
raised to 1/3. Any question? Any question?
No.
None. Okay. Okay, so this time, children, since there's no question, I'm going to continue with your complex numbers. Okay, complex numbers. So we're going to deal now with your imaginary number I. Okay, so I'm going to erase this right now. Alright, so now let's proceed with page 47 of your books. Children, Introduction to Complex Numbers. Alright, so always remember that we have imaginary unit I, which we have this values. So your I is always equal to the square root of -1. So if we're going to square this, so you square your I, that will become I squared. Then you also square your square root of -1. Okay? And actually, the square root of -1, makancel ang imong square root and your exponent. What will remain there is -1, which means that your I squared is equal to -1. So you are going to always remember these two values. I is equal to the square root of -1, and I squared is equal to -1. Alright? Okay, so now let's express our terms here to its imaginary number. So children, please turn the page on page 48 of your book. Example, so letter A there. So we're going to get express the square root of -25 into its imaginary form. So how are we going to do that? Okay, so you're going to factor out your -1 from -25. Okay, so that's gonna be 25 times -1. Okay, that's very easy, because if we're going to multiply 25 and -1, you will get -25, right? So the next thing that you're going to do is you can separate your square root of 25 and your -1, right? So that's going to be expressed as 25, or square root of 25 multiplied to the square root of -1. Okay, no problem din, Rosel. Now we can get the square root of 25, which is equal to, what is the square root of 25, children?
5.
5, very good. And let's go back to the value of your square root of -1. Okay, what is square root of -1? I. So which means that the square root of -25 is equal to 5i. Any question?
No.
Any question? Now let's proceed with letter B. So square root of -13. Okay. Oh, how about square root of -13? How are we going to solve this? Any idea? What is your answer? Okay. Okay. So we're going to, yes, Chauncy, correct. We're going to factor out your -1 from -13. Okay. So that's gonna be the square root of 13 times negative 1. And then you can separate the two factors. So that's going to be square root of 13 times the square root of negative 1. Okay. So children, 13 is not a perfect square. We can leave it like that. So square root of 13 still. And we can get the value of your square root of negative 1, which is equal to I. So your answer is square root of 13I. Okay. Children, if you see on your book that I there is actually expressed first, no? It doesn't matter. Whatever is the placement of your I there, because I could be a variable as well. Okay. It could be a variable. And actually, in multiplication, multiplication has a property which is, what is the property that we could apply here whenever we change the position of your square root of 13 and I? So I will become first, then third square root of 13.
Sir, ginano mong negative 1?
This one.
Yan.
You go back to your condition, not condition, given value of your I. Okay.
Sir.
Replace the square root of negative 1 with I. Right? Okay, so again, children, what property of multiplication we illustrate here? Even though we interchange the positions of your square root of 13 and I, that could be also equal to I square root of 13. What property of multiplication? Huh? Hello?
Wala ba dyan?
Wala?
Accept.
Okay. Alright. So we have like commutative property, right? So it doesn't actually change the answer whenever you change their position. Okay, so now let's proceed with your letter C, which is actually letter C. We still have 2 more minutes. I think we could finish this. Okay, 2 more minutes. Alright, letter C there is
Complex is sir, no? Ang
Yes.
sa dire.
complex. Alright, so we have square root of negative 48. Okay. Right? So look at this one, children. So now we could actually get the factors of your negative 48. So factor out your negative 1. Okay, that's the first thing that you're going to do. Factor out your negative 1. So that's going to be 48 times negative 1. The next thing that you're going to do is you think of the two factors, okay, the two factors that is equal to 48, and you have to also think that the one of the factors should be a perfect square. So what are the two factors which has the highest perfect square for the number 48? What is the two factors? Okay, children, 16 and 3. Very good. That's gonna be 48 could be factored out as 16 times 3 times negative 1. Okay, you can separate everything here. So that's gonna be square root of 16. That's gonna be times square root of 3 times square root of negative 1. So square root of 16 will give us 4. There's no square root for 3. Just leave it square root of 3. Then square root of negative 1 is I. So your answer is 4 square root of 3 I. Any question? Any question?
Do what, sir? Ano, sir?
Square root of 16 is equal to 4. Just copy your square root of 3 because we cannot express it anymore or simplify it. And your square root of negative 1 is actually equal to I. So your final
Ano
answer
answer,
is
sir, oh?
this one. 4 square root of 3 I. Okay? Alright, so we're going to have some examples on page 56. So we're going to solve or express our number there in terms of imaginary number, in terms of I. So let's use number 1 as our example, that is negative square root of negative 144. Okay, so of course, children, you're going to get the factors of your negative 144. Factor out your negative 1. Okay, so if you have your negative there, always copy it. Then factor out your negative 1 out of negative 144. So that is the square root of 144 times your negative 1. Okay, and then the next step
Complex
is,
ni Japan, sir.
yes, it's complex. The next thing is we're going to still copy your negative, and then separate your square root of 144 times negative 1. So that will become square root of 144 multiplied to square root of negative 1. So to simplify it further, so the square root of 144 is actually equal to how much? 12, right? And your square root of negative 1 is equal to I,
I.
right? So that will be your answer for number 1 on page 56, letter A. How about for number 2, children?
Wait na, sir.
Okay, square root of negative 49. By the way, children, the key here for you to be able to solve for the square root of numbers is that you're going to memorize or at least familiarize the perfect squares. Now you start with 1, 4. Okay, 1 times 1 or 1 squared equals to 1, 2 squared equals to 4, 3 squared equals to 9, 4 squared equals to 16, 5 squared equals to 25, 6 squared equals to 36, 7 squared equals to 49, 8 squared equals to
Page
64.
na to gani, sir.
Page 56. Okay, children, so the concept, okay, what I mean is that you could easily get the square root of a number if you know exactly their squares. Okay, so now for square root of negative 49, let's factor out your negative 1 out of negative 49. So that is 49 times negative 1. Then you're going to separate. Okay, so that is equal to the square root of 49 times square root of negative 1. So square root of 49 is 7 and negative square root of negative 1 is I. Any question? Okay, so now what if we have a fraction? Okay. Excuse me. What if we have a fraction there? So that is square root of negative 4 over 25. Okay. What if we have a fraction? So actually, children, that is really easy. Okay. If you encounter this one, this is actually a fraction and this is enclosed in a radical sign. So just separate the two. So this is actually equal to the square root of negative 4 all over the square root of 25. Okay, children, right? Next thing is you factor out your negative 4. So you factor out negative 1. So that's gonna be 4 times negative 1. Then this is still square root of 25. Then separate it. So that's gonna be square root of 4 times square root of negative 1 over square root of 25. Okay? So next thing is simplify your square root of 4. Square root of 4 is equal to 2. And then your square root of 1 is equal to I. All over square root of 25 is 5. So this will be your answer. Any question? None? Okay. So what if we have I raised to, let's say 37. Okay. What about if we have that? So how are we going to solve for the value of your I raised to 37? Okay. What are we going to do first, children? Okay, so you can express this also as I raised to 36 and times I, because 36 times 36 plus 1 will give you 37. Then think of the possible factors of your 36. So that is I raised to 4, right? Times 9. Tama? 4 times 9 is 36. 9, 18, 27, 36 times your I. Okay? And then going back to the first page, the previous page that we have, so I raised to the 4th is equal to positive 1. Correct? I raised to the 4th is equal to positive 1. Okay? Correct, children? This one is equal to 1 raised to 9 times your I. So I raised to 9, that is actually, you're going to make your 1 as a factor. So multiply it 9 times. So 1 times 1 times 1 times 1 times 1 times 1, etc. till 9. Okay? So that's still equal to 1 times your I. And 1 times I is equal to I. So the answer is still I. Any question?
Go.
None. Okay. So this time, children, so this is really important that we are going to know this, no? So this time we're going to have, or we're going to express our numbers in complex number. Okay? So children, a complex number is actually has two terms. So you have your A as your real number and your BI. This is your imaginary number. So again, it is a binomial. Complex numbers are actually binomials which have your real number part, okay, denoted by your A, and your imaginary part which is denoted by BI. Children, basta may I gani ang imo nga number, so that is considered as imaginary. Regardless if that is a big number, basta may I, it's still imaginary. Okay? But if your number is like 3, that is real number. And you cannot combine your real number and your imaginary number. Usually, if you have your 2i as your imaginary number and 3 as your real number, it will not be combined, but you can write it as like 3 plus 2i. You understand? You cannot combine your numbers. Okay? But if we're going to add your complex number, look at this one, children. I'm going to erase this. So how about if we have your 3 plus 2i, okay, plus 5 plus 3i, okay. So if you're going to add, of course, you add the real number parts and you're going to add the imaginary number parts. So that is 3 plus 5, then that is equal to 8, plus, then 2i plus 3i equal to 5i. Right? So you cannot combine your real number and your imaginary number. But if you're adding two complex numbers, so you're going to align them, right? Align your real numbers and align your imaginary numbers. Then combine your real numbers and combine your imaginary numbers. How about if we have like -4 minus 6i, then plus let's say 7 plus 2i. So how about if we have this? So you're going to add it algebraically. Of course, if you're adding two integers, you're going to, what I mean, if you're adding two integers which one is a negative and the other is positive, so you're going to subtract them. So subtract the smaller number to the bigger number. So 7 minus 4 will give you 3, and then copy the sign of your bigger number. So the sign of your bigger number is positive since 7 is bigger than your 4. And then, yes, proceed here. So if you have your -6i plus +2i, so of course you're going to add them algebraically, right? So perform subtraction since the one is negative and the other is positive. So subtract the smaller number to the bigger number. So the smaller number is 2, then subtract it from 6. So 6 minus 2 will give you 4, and copy your I there. And copy the sign of the bigger number. So the bigger number is 6, therefore the sign that we're going to follow is the sign of 6, which is negative. So your answer is 3 minus 4i. Any question? Any question?
No.
Okay.
No, sir.
Sakit ang ulo. Why is it that your head is aching, din Rosel? Alright. So now, children, now let's go to subtraction. This time, subtraction.
Sir, Diane, sir, screen. Kasi right po na ako.
Let's subtract this time. So 2 plus 8i minus 3 plus 2i. Right? Children, if you are subtracting, always make sure that you're going to change, again, if you're subtracting, always make sure that you are going to change the sign of your subtrahend. The subtrahend is the number that you usually subtract from your minuend. So the subtrahend here is 3 plus 2i. Then if you're going to perform your subtraction, change the sign of your subtrahend. So the sign of your subtrahend is positive 3. So that will be changed to negative. And your imaginary number there is positive 2i. Change it to negative. Then proceed to the rule of addition. Okay, proceed to the rule of addition. So this time we have 2 minus 3. So you're going to add them algebraically. So 2 minus 3, you're going to subtract since the other one is negative and the other one is positive, right? So subtract 2 from 3 will give you 1, and copy the sign of your bigger number, which is 3 here, negative. Okay? This time we have your 8i minus 2i. So of course, that's going to be 6i, and the sign that you're going to copy is the bigger number, right? So 8 is bigger than 2, so your sign is positive. So that's how you're going to subtract. Again, to subtract, change the sign of the subtrahend and then proceed to the rule of addition, right? Now let's have your multiplication. Okay, so 2 plus 2i multiplied by 2 minus 3i.
Ang una gani, sir, ano na siya, sir? Ang 3
Yes.
plus 2i. Ano
Addition.
sa ang una? Addition na siya.
Addition. This one is also addition. Addition, same sign. Addition, different sign. This one, no matter what is the sign, always change the sign of your subtrahend, then proceed to the rule of addition. Okay?
Okay.
Sa rule of addition, we have your 2 positive signs or 2 negative signs, so add them. We have your 2 positive and negative, then you're going to proceed with this as well. Okay? So 2 rules in addition, but for subtraction, always change the sign of the subtrahend. Now for multiplication, children, of course you can actually apply your FOIL method. Okay, always apply your FOIL method. So first you're going to multiply the first terms, the first terms I mean. So that is 2 times 2, right? 2 times 2 will give you 4. Then multiply the terms outside. So you have your 2 and negative 3i. So 2 times negative 3i will give you 5i. Multiply 2 times negative 3 is 6.
6i, sir. Negative
Alright.
6i.
Correct. 6i. Then, okay, multiply the inner terms. You have your positive 2i and positive 2i and positive 2. So 2 times 2 will give you positive 4i. Okay? And lastly, your last terms. Okay? 2i or positive 2i times your negative 3i. So 2 times 3 will give you negative 6i. Okay? If you are multiplying, children, you are adding their exponents. So I times I is
6i.
I squared. Okay, so that is equal to 4 minus 6i plus 4i minus 6i squared. So now we're going to simplify this. So 4, children, now you have negative 6i plus 4i. So you combine this one, you will get negative 2i, right? So subtract 4 from 6 and then copy the sign of your bigger number. The bigger number is 6, therefore it's negative. Okay, and then negative 6i squared. So negative 6i squared. But we have to remember that your I is equal to square root of negative 1 and your I squared is equal to is equal to negative 1. Right? Is equal to negative 1. So that is 4. So negative 2 times your I, which is square root of negative 1, minus 6, and then your I squared is negative 1. So now let's simplify it further. Okay, so that is 4 minus 2 square root of negative 1. Okay, and then negative 6 times negative 1 is how much? Children? Negative? Positive 6. Okay, so you're going to combine your 4 and 6. What is 4 and 6? It is equal to 10 minus 2. By the way, ibalik mo yung mga value of square root of negative 1 to I. So your final answer is 10 minus 2i, right? So if you're going to multiply 2 plus 2i times 2 minus 3i, the answer is 10 minus 2i. Any question?
No.
None?
None,
Okay.
sir.
So that would be all, I think, children, no? But for your division, always get the conjugate of your divisor, okay? Always get the conjugate of your divisor. So that is for your division. Okay, when we say conjugate, you're going to get the opposite sign of your divisor. Say for example, we still have 9 minutes. Okay, let's have one brief example for division. So this time we're going to divide. Okay, so let's perform. Wait for a while, children. Let's perform letter A. Okay, letter A on page 55. Example number 9. Okay, so we're going to divide negative 5 plus 9i by 1 minus 2i. So again, children, we're going to use your conjugate. Okay, we're going to use your conjugate. So the conjugate of your 1 minus 2i, what is the conjugate? That is Okay, change the sign. Okay, whatever's the sign there, if it's negative, then you're going to change it to positive. Right? Do you get me, children?
Yes.
Alright? Any question? None? Right. So, you're going to use this, children, no? As your i-multiply mo diri sa imong given. Right? So, you multiply both the numerator and denominator. Okay? Because actually, we're going to multiply it by 1, right? But, diba? 1 could be expressed as 1 plus 2i over 1 plus 2i. This is actually equal to 1. So, if we're going to multiply it by 1, we are not actually changing the whole thing. We are not doing something on the number because we are just only multiplying it by 1. And in the rule of multiplication, whatever number multiplied it by 1, the answer is always that number. So that is the identity element rule in multiplication. But we're going to replace your 1 there instead with your conjugate, which is actually 1 plus 2i over 1 plus 2i. Okay? So replace natin si 1 with 1 plus 2i over 1 plus 2i. So 1 plus 2i over 1 plus 2i. Actually, we are only multiplying our numerator and we're also multiplying our denominator. Okay? So you can use your FOIL method here, children. Medyo malawig-lawig siya, no? So negative 5 times positive 1 is negative 5. Okay? Outside term, negative 5 times positive 2i, that is negative 10i. Then your inner, positive 9i times 1 will give you positive 9i. And then your 9i and 2i will give you 18i squared. Okay? And then that is your numerator. Now your denominator is like this. So 1 times 1 will give you 1. 1 times 2i will give you positive 2i. Negative 2i times 1 will give you negative 2i. And then your negative 2i times positive 2i will give you negative 4i squared. So this one and this one will be cancelled out, right? So negative 5. So negative 10i plus 9i is negative I. Tama? 1i or I. Plus, children, 18. Okay? 18i squared. Right? So I squared is equal to negative 1. All over 1 minus 4 times I squared is equal to negative 1. Okay? So let's combine everything there. So negative 5 minus 18. Okay, negative 5 minus 18. Since positive 18 times negative 1 is negative 18, so that is negative 18, right? Negative 18 minus 5 is how much? Negative 22. Okay, minus I. Then here we have your 1 minus minus. So 1 plus 4. 1 plus 4 is how much? 1 plus 4 is 5. Okay. Oops. Dali lang. 5i minus 18. Okay. Negative. Sorry. This should have been 23, not 22. Right? By the way, children, negative 5 minus 18 or negative 18 minus 5, that is negative 23. Alright?
Yes.
Okay, so sometimes, children, you have to make sure your addition because we have the same negative sign, which means you're going to add them now and just copy their sign, which is negative. So you have your negative 23 minus I over 5. So this is already your correct answer. But if we're going to separate this, that is equal to negative 23 over 5 minus I raised to minus I over 5, I mean. So that will be your final answer. Okay? So again, whatever is your divisor, get the conjugate, then divide it by 1. So whatever is your conjugate, children, the same man ang denominator. Then what we're going to do, multiply your numerators, no, using your FOIL method. Then multiply also your denominators using your FOIL method. Then simplify your numerator, simplify your denominator, and then if you can have there something to divide, you can also do it, right? For example, being answer that is 25 over 5. So of course, so 25 divided by 5, the answer is whole number, like 5, right? And then minus I. Right? Any question?
No.
None. Alright. So that will be all for today, children. So thank you so much for your time. I hope that you have gotten or reviewed something or recalled something from our past lessons, and you could apply them to our exam for tomorrow. Alright? So thank you so much for your participation and attendance today. So I'll be giving additional points to Chauncy, French Diane, Andrei, then Rosel, who else? I think Rovi is here earlier, and Azer Hamilari. Of course, for those who have stayed until the last minute of our time this afternoon, you will get more points, of course. Okay? So all of you children, I'll give you plus 20 points. Alright? Alright, thank you so much, children. God bless, Merry Christmas, and Happy New Year. Any question?
Happy Christmas.
Okay, sir. Thank you. Advance Merry Christmas.
Yes. See you tomorrow at 9 o'clock, children. Alright, goodbye,
Okay, sir.
goodbye. Take care and have a good night rest tonight. Bye-bye.
Yes, sir. Thank you.
Welcome.
Kumbrap ko, sir.